everyone. So today's topic is chemical reactions and chemical equations. So we are going to learn what is a chemical reaction, what are different types of chemical reactions, how to write a chemical reaction, and also few concepts like corrosion and Ranacidity. So let us move on to the topic. And if you are coming here for first time, please do consider subscribing to my channel. So, what is a chemical reaction? Tell me. Do you know? When reactants transform into completely new product with different chemical properties, then you call it as a chemical reaction. Okay. So you should also understand that the atoms don't disappear, they just rearrange into new bonds. Now, how do you actually spot that chemical reaction has happened? So there are 6 signs shown on the screen. First one is change in state. Yes, there may be a change in state, and there is a change in color, evolution of gas, change in temperature, and in few reactions there will be formation of precipitate, and for few reactions there will be evolution of light. So these are the different characteristics you can look when a chemical reaction is happening. Okay, so now let us talk about how to write the chemical reaction. A chemical reaction is shown using chemical formulas. Okay, so the reactants are written on the left side and the products are written on the right side. So here, for example, magnesium and oxygen reacts together to form magnesium oxide. Is a reaction, is a chemical reaction. And how do you represent it in the form of a chemical equation is the question. So here, why do we need to write that in a chemical equation? Yes, to save space, to understand what type of product is formed, and also you should also understand about law of conservation of mass. That is nothing but the mass on the reactant side should be equal to the mass of the atoms on the product side. Okay, so look at the reaction. Magnesium plus oxygen gives rise to Mg2O. Is the reaction balanced? Is the mass of atoms on the left side are equal to right side? No. So to balance this, we are going to write 2Mg plus O2 gives rise to 2MgO. So this is called as balancing a chemical reaction or chemical equation. So balancing a chemical equation, we can do this in different methods. So here first one, trial and error method. So you can look at the example, iron and water gives rise to ferric oxide and water. This is the chemical reaction, and to write it in the form of a chemical equation or with a balanced equation, what you should do is, first we are going to look at the which is having more number of atoms. So it is Fe3O4. So first we are going to balance the iron on both sides. So multiply by 3 on the reactant side for iron, and then we understood that it is balanced. And when we go into the balancing oxygen, we need to write 4, and then we need to balance also the hydrogen atoms. So here the final balanced equation will be 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. So as we discussed in the earlier case, so to represent the state of the reactants or the state of the products, we use these as a subscripts. Okay, solid, liquid, gas or aqueous. So these things we are going to mention as a subscript. Suppose if we look at the reaction, CaCO3 is a solid. When heated, it gives CaO and CO2 as gas. CaO is a solid and CO2 is a gas. So this whole reaction can be represented in the form of a chemical equation. We need to also mention the state of the reactants and products. So here, what are the types of the chemical reactions? We have mainly 5 types of chemical reactions. So as you can look on the screen, they are combination reaction, decomposition reactions, displacement reactions, double displacement reactions, oxidation and reduction reactions. So here, try to remember the names, and from the name itself you will be able to understand what type of a reaction is happening there. So first one is combination reaction. When two reactants A and B combine to form AB, it is called as a combination reaction. Understood? And decomposition means they are dividing into two different products. So when AB gives rise to A plus B, then it is called as a decomposition reaction. So displacement reactions means they are going to displace one of the metal, that we are going to learn based on the reactivity series. Okay, and if two metals are replaced, then it is called as double displacement reactions. So we will discuss each type in the coming slides. Okay, combination reaction is the first type. Two or more substances to join to form one single product, that is called as combination reactions. Okay, so when quicklime and water is reacted to form slaked-lime, carbon burning in the oxygen gives carbon dioxide, and hydrogen burning in the oxygen gives water. So these are the examples for combination reactions. You can see that two chemical compounds are combining together to form new compound. Okay, you should understand the properties of the reactants are different from the chemical properties of products. So here there is a special case. Combination reactions that release heat while forming the products are called exothermic combination reactions. Okay, carbon and oxygen reacts to give carbon dioxide and heat. Remember, respiration in our cells is also an example of a exothermic combination type of reaction. It releases energy which our body uses. So simply you remember, A plus B gives rise to AB. Understood? So let us move on to the next one. What is a decomposition reaction? So I told you already, when one compound breaks into two or more simpler substances, then it is called as a decomposition reaction. So here there are three types of decomposition reactions. One is thermal decomposition reaction, then electrolytic decomposition reaction, and photolytic decomposition reaction. So here let us look at each examples. Limestone breaking into quicklime and carbon dioxide is a classic example, and this is how cement is made in the industries. Okay, so electrolytic decomposition needs electricity. Thermal decomposition means you understood that heat is given, and in the electrolytic decomposition electricity should be provided. Electricity will be splitting water into hydrogen and oxygen, and in photolytic decomposition reactions we need light. Photo means light. Light breaks down the compound. So AgCl gives rise to Ag and Cl2. Okay, so here that is the reason AgCl2 is always stored in a dark place, because when it reacts with light it again decomposes into 2 Ag and Cl2. So we are starting with displacement reactions. I told you already, that means the metals which are more reactive displaces the less reactive metals. Okay, so we have already learned the reactivity series, right? We know that potassium, sodium, calcium are higher reactive, and copper, silver, gold are less reactive. So all the higher reactive metals will replace the less reactive metals. This happens in a displacement reaction. So for example, a metal can only displace another metal that's below in the series. Zinc displacing copper and zinc displacing hydrogen from dilute acid are the two examples you can remember. So next topic is double displacement reaction. Double displacement reaction is nothing but when two compounds swap ions with each other, giving two brand new products, then it is called as a double displacement reaction. So look at the reaction in the short form. AB plus CD gives rise to AD and CB. Understood? So here this also follows the same reactivity series, and example is sodium sulfate plus barium chloride gives rise to, they are going to interchange the partners and we are going to get barium sulfate and also sodium chloride. Okay. Let us also look at the other reaction. AgNO3 silver nitrate and sodium chloride gives rise to silver chloride and NaNO3. What is the difference between the combination reaction and double displacement reaction? In combination reactions we get only one product, but in double displacement the exchange of ions takes place and it forms two new products. Don't get confused between these two. Okay. Next is oxidation and reduction type of reactions. Remember it as oil and rig. Okay. Oxidation is loss and reduction is gain. Okay. But oxidation is gaining oxygen or losing hydrogen. Reduction is losing oxygen or gaining hydrogen. Now here is an important thing. In redox reactions, both oxidation and reduction happen at the same time. This is called as a redox reactions. So CuO, that is copper oxide plus hydrogen, gives rise to copper plus H2O. So very slowly it happens and copper oxide loses oxygen, so it is reduced to copper, and hydrogen gains oxygen, so it is oxidized to water. This is very important reaction for which is an example of oxidation and reduction reaction. Okay. Here we have other type of reactions, that is exothermic and endothermic. So you should understand that it is more about energy. Okay. The reaction which is giving heat or which is taking heat, that is the main difference. So exothermic reactions release heat to the surroundings by burning any fuel, respiration in our body, compost forming from decomposing vegetable matter. All these are examples of a exothermic reaction. Adding quicklime to water. So these all are exothermic reactions. And what about endothermic reactions? They absorb heat from the surroundings. And endothermic reactions examples are thermal decomposition, electrolytic decomposition, photosynthesis in green plants, then melting of ice, evaporation, photolytic decomposition. All these are examples of endothermic reactions. These things you will get in the bits also. So please try to remember. So what is a corrosion? When a metal surface is slowly eaten away by moisture, acids or gases in the air, then this is corrosion, and it happens through the oxidation of the metal surface. So here we know the best examples are rusting of iron, which is actually reddish brown and flaky coating of hydrated iron oxide, then tarnishing of silver, black coating you see on old silver jewelry caused by sulfur compounds in air. Okay. And the green coating on the old copper statues or vessels, that is also due to this corrosion only. So how to prevent this corrosion? Yes, we can paint, we can do oil or greasing, then galvanizing and alloying. So these are the few methods to avoid corrosion. So this is also, these all things were also discussed in the metals concept. If you want, you can check in the everyday example of oxidation is rancidity. When fats and oils in food get oxidized over time, they develop unpleasant smell and taste. And actually, there is no visible mold, but you get unpleasant smell from the packed foods. So what happens? They, to avoid rancidity, they infuse those packets with nitrogen gas, or they have different methods actually. And they keep it in the airtight containers, or they use vacuum packing, that is nothing but removing air from the packet before sealing. And we should also store the things away from the light. So what all we learn in today's topic? We have learned entire chapter, uh, how to write the chemical equation, then what are the different types of chemical reactions, then how does the energy changes, and even we have learned that is corrosion, how to prevent it, rancidity, and how to prevent it. Okay. So try to remember the key reactions at a glance. If you want, you can take this one screenshot. Go through all the types of important reactions. Remember, understand it, understand them. And here is a 1 mark questions. Try to answer. These are the 3 marks questions which are coming repeatedly from the board exams. And these are the important 5 marks questions. Kindly go through. So walk into the exam with confidence, children. If you like this video, please hit like, subscribe, so we can tackle every remaining chapter together, and comment one thing which you have learned from today's video. Thank you.